Hey, students, checking out 6.2 as we look at the homework section. So we have 1 through 8, 10, 13 to 14, and 16 to 18. So if you basically look and say 1 through 18, and I have skipped intentionally number 9, 11, 12, and 15. So let's take a look at the homework. Do, 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 do. All right, so again, you do have some questions that ask you to perform addition or subtraction. This is getting you used to working with fractions again. Some of them will be mixed numbers. Some of them will be proper fractions. Some will be improper fractions. Don't worry about that. Just get used to the idea of, let me get a common denominator, or if you prefer that additional approach that I showed in the video, when dealing with mixed numbers, deal with the whole number parts, then deal with the mixed number parts as you go. That might be a little quicker way to deal with some of these things. Oh, let's see here. Change each of the following fractions to a mixed number. So again, this is the division algorithm. What's your quotient? What's your remainder? Change each of the mixed numbers into a fraction. All right, that's fine. So now think about it. Take a fraction, turn it into a mixed number. Take a mixed number, put them into a fraction. You're just going forwards and backwards. A little bit of an explore activity because you know you have to get a denominator of 24. So think about where would you put these different components so that you could get a denominator of 24. As a hint, putting a 5 in the denominator might not be the best because then a common denominator would not be 24. It'd have to be a multiple of 5. Question 5 lists how many games they played and how many games they won. So for example, when you look at these, the goal is that you're able to estimate because we're looking at kind of being able to do estimations quickly. For example, this team that won 8 games out of 23 games, think about it, 8 and 23, that doesn't work perfectly. Wouldn't it be better if it was 8 and 24? And 8 and 24 turns out to be 1/3. So now you've got a benchmark fraction that you can kind of link this up to. And notice the denominator here is bigger. So what does that mean about my benchmark fraction? Is my benchmark larger or smaller than the number I'm looking at overall? Okay. All right. So a couple there. Sorting, like we said before, sort these. Where should they go? Which ones are about a half? Which ones are about 1? Which ones are about 0? And then you get to do the same type of thing with some benchmark fractions. 0, 1/4, 1/2, and 3/4, or 1. And then you need to say whether your estimate, which again would be one of these numbers, is too high or too low. So as an example for the first one, 113 over 100, that is pretty close to the number 1, but 1 would be 100 over 100. So that number 1 as an estimate would be lower than 113 over 100. Okay. Love these questions. Hint, hint, nudge, nudge, wink, wink. Love these for tests. Without finding the exact answer, state which of the given numbers in parentheses is the best approximation without actually calculating the numbers. So this is where you get to use your estimating skill and come up and kind of say, hey, this looks like it is the closest and best value. Okay, what did I say here? Skip number 9. Okay, well, you'll skip number 9 then. Now, it does say compute them mentally, so you might be able to do these mentally, even though you are skipping the problem. Here's M, A, T, and H. You'll notice they are chunks on a ruler, and you're using mental mathematics to kind of figure out where would a particular measurement fall. Okay. Mental mathematics, be thinking about how many groups of, as an example, 9 over 8. How many groups of 8 are in 9? And definitely 1 with a little bit left over, but not as much as 2. So for the first one, I would say that that falls into region M. And let's see here, 1/4 freshmen, 1/5 this, 1/10 are juniors, the rest are seniors. Hey, if you add all these fractions together, you'll find out the fraction that is in those 3 groups, and you can figure out what's remaining behind them. And let's see here, 12. Oh, I skipped 12, that's right. There we go. And what did I get back to? 13. So I said 13 and 14. Okay. Recipe requires this much milk. somebody put in this many cups into a bowl. How much more milk does he need? The board is cut. The saw cut takes this much. So if you go through and cut this much off a board, but the saw, again, when you're cutting something, it's usually not a perfect cut. The saw actually eats up part of the wood. So how much is left over? Let's see here. Insert 4 fractions between these so that the numbers constitute part of a. This is the one. Number 16. Of course I assigned that one. I do enjoy that question because it says insert fractions between two numbers so that the however many numbers we want, including 1 and 3, constitute part of an arithmetic sequence. So this links back into what we did in chapter 1. It links back into what we did in chapter 2. So you have 1, blank, 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 and then you hit 3. The question is, what are these numbers and fractions, because they won't be whole numbers, that would actually make this a perfect arithmetic sequence? Remember what we know about arithmetic sequences. They have to have a common difference. And so if you thought about how many common differences would I have to add to get up here, you might be able to see how to solve that problem. I'll let you give it a try. Joe has paint. He uses some and then he adds more. How much does he have left? Pretty common type questions. And I think that's it. I stopped at 18. Okay. There are some more there with data, but I'm not going to, I did not assign those. And I think after this, you get to math connections. There we go. All right. So not quite as many homework problems on this one. Math connections is coming up next. Off you go.